Hello everyone and welcome back to Mathematics. So to this video, we'll be focusing on this year's trial paper for Sabah paper 1, and I would say this paper, most of the questions quite okay, it's just that a few questions are special and rarely comes up. For example, questions 5, 9, 12, 13 and 14. Because these questions need some special techniques to be able to solve them. Alright, but nevertheless, I think once you've completed this paper and you'll watch this video, it's a very good paper for your revision later on. Alright, so without wasting time, let's discuss this paper together. Right, so this paper starts off with a question from chapter functions, and here we have an arrow diagram, and in part A, we need to state the object of 4. So let's recall back a bit. The things on the left side of this arrow diagram is called the objects. The things on the right side is called the images. So now we are trying to find the object of 4. So this 4 will be the image. Okay, so if we try to find the object, it would be 2. So our answer would be 2. Alright, and for part B, we need to find out the range of this relation. So let's recall back again. For the things on the left side, another word for them is called the domain. For the things on the right side, there's another word for them which is called the codomain. And codomain and range, they are quite similar. It's just that for range are the values on the right side which are connected. So 13 is not because it is not connected. Right, so to write out our answer, we can write out in this way. So the set of values we will be putting here, and on the outside we need to put this curly bracket, or known as the set bracket. Okay, once we have a set of numbers, we need to use the set bracket. Without this set bracket, you will be deducted marks. Okay, so please remember this. And for part C, we need to use the function notation, which means we need to use the f of x way to find the expression of the relationship between these two sets of values. So let's list down all of them here. And for the 13, I'm going to ignore it because it is not connected. Right? So from here, let's find the relationship between the pair of numbers. So for the second pair, we can find it actually because 2 multiplied 2, you can get 4. Right? So since one number is multiplied with 2, then the rest need to follow. But this creates an issue because once I multiply 2, I still couldn't get the value on the right side. For example, the first, third and the fourth pair. So what we need to do is to find an adjust value, meaning from the value on the left side to adjust it to the value on the right side. So means find the difference lah. So for example, 1 times 2, to get to 1, we do minus 1. For 2, this one no need, so we just add 0. For these two, from 3 times 2 and 4 times 2 to get 7 and 10, we need to plus 1 and plus 2 respectively. Okay, so these are the adjusted values. So now to find the pattern of these adjusted values, let me use back the values on the left side because these are also changing. Right? You can see that these values, the adjusted values, they have a pattern. So which is adding 1. So I can use back the left side values because these values are also adding 1. So means if I find the difference between the orange values and the adjusted values, I can get a common value. Okay, so for example, from 1, how to get to minus 1 is minus 2. From 2 to get to 0, I also minus 2. For 3 to get to 1, I also minus 2. You can see that all of the values need minus 2 to get the adjusted values. Okay, so now you can see that we have found our pattern. Right, so to make sure it is the function notation, we need to make sure that the values which are changing, we need to change it to x. Okay, because we are using the function notation way. So now once we have this, we can just simplify it, and then we can get our function, which is f of x equals to 3x minus 2. For our next question focuses on the indices, surds, and the logarithms chapter, but here we are just focusing on the indices part only. Alright, and for the two equations here, we need to find the expression where n is in terms of p. So means n must be on the left side, everything must be on the right side. Okay, so for the first part, let's put all the things which has n to the left side. Okay, for example this one, I'm moving it to the left side. So since these two values have the same base, so base I'm referring to is this value, the 2 here. Okay, so since I'm moving this to the left side, means I am multiplying the values, and since both of them have the same base, I can add up their power, right? And now if you compare left and right side, they have the same base value. So what I'm going to do is I'm going to compare their powers and to find the expression. Okay, so for the right side, they actually have a power which is 1. Okay, it's not written out because it's not required lah, but there's a power of 1 here. So what I'm going to do is compare the power, and then I'm going to move everything which is not n to the right side and to find the expression. Okay, for part B, similar thing as well. Okay, for the things which has n, we're going to move it to the left side. So before that, if you look at the base value, actually this 25 we can change it to where the base value is 5. Okay, so 25 is actually 5 square also, so we are going to change it to this form. Alright, and here I'm going to split. Okay, so means the plus here, because the power is added, so when I split, it will be multiplied. Okay, so now on the left side, this means that I have 5 of these values here, the 5, 2, and p. I have 5 of them. And on the right side, I have another 1. So if I'm moving this to the left side, means I am adding another 5, 2, and p to the left side. So from 5, now you have 6 of them. Okay, that's why there's a 6 here. And what I'm going to do is to put the 6 to the right side, and now we can get this 1, 2, 5. So now, actually this 1, 2, 5, we can also change it where the base is 5. Because 1, 2, 5 is also 5 to the power of 3. Okay, so let's change it in that way. And now, similar to part A, I'm going to compare the power because now the base value is the same. Okay, so now everything which is not n to the right side, and we can find our expression. For next question, we are still at the same chapter, but now it's just focusing on logarithms. Alright, so in part A, we need to simplify these 3 logs, and now I'm going to introduce you all a way which helps you to solve any kind of logarithm question by using this 3-step method. Right? So the first step is to change the base. So a rule of thumb to change the base is always changing the logs which have larger base to the smaller base. So now if you see, we have the base of 2 and 4. Right? So means I'm going to change the base which has 4 to 2. Okay, so changing base quite simple. We are just going to put the value of the log on top and the old base at the bottom. And I'm going to put the new base here, which is a smaller base, which is 2. Okay, so this is the first step. And now the second step is to manipulate. So meaning manipulate this expression, and we simplify even further using these formulas. Okay, so for example, for the denominator part, we can actually simplify. So for the 4, I can adjust it in a way that the base value is the same value here, which is the log base value is 2. So the 4 here, I can change it to base is 2, and if I'm using base is 2, that means 2 to the power of 2 lah, right? Because 2 to the power of 2 is 4. And then now I can use this formula to move the power in front. Okay, as you see here, move the n to the front. So this 2, I can move it to the front. And now if you see things on this part, the base value and the log value is the same. So we have learned that if the base and the log value is the same, then we can change it to 1. So in the denominator part, we only left with 2. And this 2 can be divided with 4. So here will end up as 2 log base 2 x squared. Right? So now, these 3 logs, if you want to simplify even further, we can combine them actually. Okay, but first thing first, we need to remove these powers in front. Sorry, these values in front. Okay, so what I'm going to do is use back the same formula. It's just that the value of n, I'm going to move it back to the power part. Okay, the n, I'm going to move it to the power part. So here, for this log, 2, I'm going to move it back. So 2 times 2, 4. And for the value of 3 here, I'm going to move it back. So here will be x to the power of 3. And now we can combine them. So combine them, we need to use these 2 formulas. So for the values which are positive, it will be multiplied. For those which are in negative, we need to divide. Okay, so for the positive values, we have 2x minus 1 and x to the power of 3. So we're going to multiply them. And for this log is in negative, so we are going to divide it. So once we simplify this, then we will get the simplified expression, which is this one. Alright, and there's another step here which we didn't use, which is to change the form. Okay, this one I didn't use is because we are just simplifying. Right, so we don't need to change the form. But this step will be useful for questions like in part B, where you see that there is an equation. And equations, usually we do change the form. Right? So let's look at part B. So we need to find the expression of y in terms of x. So means y on the left side, everything on the right side. And you will see that there is this value of e. Okay, so where does this e come from? It's actually from the log here, or we call it as ln, L-O-N. Okay, this ln is actually a special case of log where the base value is e. Right? So if you type your calculator of e1, okay, you will see there's a value. So that value is the value of e. Okay, this is just a value. Alright, so now to find the expression, what we can do is we are going to group the values that has ln. Alright, so I'm going to move this to the right side, okay, and then I'm going to switch their places to get something like this. Alright, so now, since for the logs here, they have the same base, so for step 1 we can just ignore. Okay, we are going to straight jump into step 2, just to manipulate. So to simplify this even further, what we can do is to combine them. So to combine them, we can use the 2 formulas here. So if it's adding or positive, we are going to multiply. If it's negative, we are going to divide. So positive value put on top, negative value put at the bottom. Alright, so now we cannot simplify further, and this is where the third step comes in. So here it's actually the log form. So now we need to change it to the index form, and this is very simple actually. We are just going to move the base value to the right side. Okay, so for example this ln is log base e. Okay, log base e. So I'm going to move the e to the right side, and you will get something like this. Okay, so now to find the expression of y, we are just going to move everything which is not y to the right side. Okay, including the square. So square, once I move it to the right side, you will get something like this. Okay, so whenever we move a square, we will get positive and negative at the same time. And this would be our final answer, because if you look back here, this value of y is squared. So meaning negative and positive values will all become positive values. And for logarithm values, it must be positive, right? So since negative and positive are all becoming positive, then all the values here will be accepted, negative and positive wise. Alright, so this would be our answer, and make sure to have both positive and negative in your answer. And the next question focuses on differentiation, and in part A, we need to use the first principle method to show that the first derivative of this equation would be this result. Okay, so this first derivative means that what is the result when we differentiate this equation the first time, okay, which technically is the dy over dx lah, and then we need to show this result. But the method that we are going to differentiate is using the first principle method, which using the delta y and the delta x way to find out dy over dx. And I think that this method, most of the students will be confused how do we use the first principle method, because the steps are quite confusing. Okay, so here I'm going to teach you all step by step. Okay, so before we go into the steps, I would like to set our goal first for first principle method. So our goal here is to change the left side of the equation, which is y, to become this, where delta y over delta x, and then there's a limit here. Why we need to change into this is because this is equal to dy over dx, which is the thing that we are trying to find now. Okay, so our goal is change the left side to be this. So for the first principle method, there will be 4 main steps. Okay, so the first step is for every y, I'm going to add delta y. For every x, I'm going to add delta x. Okay, which is something like this. And what I'm going to do here now is to expand the things inside the bracket, and we are going to multiply the values outside the bracket to inside the bracket. Okay, so this is just simplifying. Alright, so once we have this expression already, then we go to the second step, which is to substitute the original equation of y into here. Okay, so just now we know that y is equals to this, so for the y here, I'm going to change it to this. Okay, so here will become 2x squared minus 3x, and then I'm going to move these two things to the right side. Okay, so means I'm going to cancel off these 4 things lah. Okay, so it will be something like this. So now as you see on the left side, we have delta y already. Right, so this brings us to the third step, which is to divide delta x for the whole equation. Okay, so now for the right side, we can divide delta x for each of the values here. So I can cancel off this part, cancel off the square here, and cancel off the delta x here. Okay, so the result would be something like this. And now on the left side, we have left with this limit. So this brings us to the last step, which is to apply limit for both sides. So what we are going to do on the right side is, for everything which is delta x, which is this one, we are going to change it to 0. Because this limit says that delta x must approach to 0. So for everything which is delta x, we need to change it to 0. Okay, so on the right side, we have left with 4x minus 3 only, which is the result that we need to show. Okay, and since we achieved this thing already, so this will become dy over dx. Okay, and this would be the first principle method way. And for part B, it focuses on its related chapter, which is integration. Okay, so here we are given the gradient function of the curve. So we know that gradient is m, and we know that in differentiation, m is also equals to dy over dx. So this is the expression now. So we need to find the equation for the curve, and integration of the curve is y. So to change from dy over dx to y, we need to use the integration way. Okay, so we are going to integrate this fraction. Okay, but here we cannot straight jump into integration yet because we haven't learned the way to integrate fractions in this way. Alright, so what we need to do is, for the 3x here, I'm going to separately divide them first, the two values on top first. Okay, and we'll get something like this. So what I'm saying is, for x to the power of 4, divide with 3x to get this, and 8x squared divide with 3x to get this. Okay, so now you see that these two values are separated, and then we can integrate them one by one. Alright, so now just use the normal integration way. So adding 1 to the power, and I'm going to divide with the new power, so 3 plus 1 is 4, and we'll get something like this. And here we have already power of 1 here, so we add another 1 here, so new power is 2, and I'm going to divide with the new power. So divide 2 to get this result. And since we don't have the limits here, we are going to add c. Okay, so once we simplify, it will be something like this, but this cannot be our final answer because we didn't find the value of c yet. So what we can do is, we can use the coordinates being provided here. Okay, we substitute these coordinates into the equation to find the value of c. Alright, so once we substitute, we simplify, and then we'll get c is equals to 3, and only this would be our final answer. Okay, with the c value being substituted here. Next question focuses on vectors, and here we have an isosceles triangle, which means that the lines BC and lines BA have the same length. Alright, and we are also given the vector to go from A to B, which is this one, and this vector is actually in the column vector format. Alright, so let's understand this vector a bit. So now we are going from A to B, and here the top value, it describes the number of steps to go to the left or to the right. So now it's a positive value and it's 6, so means that we need to go to the right because it's positive, and we need to go to the right by 6 steps. Right, so 1, 2, 3, 4, 5, 6, right, 6 steps. And for the value at the bottom, it describes the number of steps to go up or go down. So now it's positive and it's 8, so we are going upwards and by 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then from A, we can reach to B. Alright, so coming back here, now we need to find the vector AC in terms of I and J. So as usual, to find a vector, we need to set our route first. Right? So from A to C. So here, very straightforward, our route will be just one only, which is from A, go to B, and then from B, go to C. So for this first vector, AB, we already have it, which is 6, 8. But what about BC? Okay, because BC, we don't have any vector and we only have the coordinates. Okay, so how are we going to use coordinates to find the vector? Right, so the first thing is, from coordinates, how do we change it to the common vector format? Okay, this one very simple. For 3, 2, I'm going to put the x coordinate on top and the y coordinate at the bottom. Same goes to point C as well. For the value of k, I'm going to put on top and -4 put at the bottom. Alright, so the first question you may ask is, why can suddenly coordinates change to column vector 1? Okay, so let me explain to y'all. So these coordinates are set based on the position of the origin, right? All the coordinates here, all will be based on the origin. If origin changes, then the coordinates changes also, right? And for the vectors, same thing as well. So now let me find the vector to go from the origin to point B. Okay, so from O to B, what I'm going to do is go 3 steps to the right first. So the vector here will be 3i and 2 units upwards. So the vector here will be 2j. Okay, so now our vector is 3i and 2j, and if we want to change it to the column vector way, is putting the value of I on top, which is 3, and the value of j at the bottom, which is 2. So you can see it's actually the same thing. Okay, so why can we change coordinates to column vector in this way? Because vectors coordinates all use the same origin point. Okay, which is why we can straight change it. So coming back to here, to find the vector BC, what we need to do is straightforward. Find the differences between these two column vectors. So what I'm going to do is find the column vector of our endpoint, which is point C, minus with the column vector which is our starting point, which is point B. Okay, so minus these two column vectors, then I can get the vector already. Right, so you all may be asking, why can suddenly minus like this? Okay, so let me run off some of the working just now. So just now I've mentioned that all of these vectors, right, all are according to the origin, right? So to find vectors like BC, actually we have used the origin point. Okay, and these are the vectors we have used. So why is it these two vectors? Okay, because this 3, 2 is actually OB, right? From O to B, which I have just now drawn to you, right? So now from B, I want to go to C. So B, I need to go through O first. So my direction is like this, B to O. But just now it was O to B. So opposite direction, we need to put a negative. That's why in the working, there's a negative for 3, 2. Okay, and now from O to C, we are going to the same direction, O to C, and this vector, this column vector is describing O to C, which is why here it's positive. Okay, that's why we can minus these two values to get the vector. Alright, so why can we use this is because we are using the origin point. And the fastest way to do this is use the final points column vector and minus with the starting points column vector to find the vector. Okay, so now coming back here, there's an issue because we don't have the value of k yet. Alright, so to find the value of k, we can use back the first information, which is the lines BC and BA have the same length. So since we have the vectors of these two lines already, we can use the vector way to find the length, which is also known as magnitude. And using this formula, very simple, we are just going to use the values in the column vector and substitute into this formula. Okay, but just to let you know, this is actually the Pythagoras theorem. Okay, if you look back at the triangle, the first triangle that I have drawn just now, the 6 and 8 here, okay, this is actually a right angle triangle. And now we are finding the length of this part. This part is actually the hypotenuse of this right angle triangle. So if you want to find out the length of this hypotenuse, it will be 6 squared, which is x squared, plus 8 squared, which is y squared, and then we square root, which is the way we find the length of the hypotenuse. Okay, so this is actually the Pythagoras theorem lah. So now coming back here, find the length of BC. So we are going to substitute these two values inside this formula, square them, add them all together, and square root. Same goes to BA as well. Okay, 6, 8 put inside the formula, square them, add them all together, and put a square root. Okay, so now both of the sides have square root, so I'm just going to cancel off, right? And then expand the values inside the bracket. Then I simplify, move everything to the left side, and then we will get a quadratic equation. So now what we can do is factorize using the calculator to get two values of k. So here we have k equals to -5 and k equals to 11. So to choose which one to select, we can look back at this diagram here. So if you look at point C, it is located here. The x value is positive, so means we do reject k equals to -5. Okay, so once we have the value of k ready, we can substitute it here and we can write it here. So once we simplify this, you will get the vector is 14, 2. And don't forget, here it says write in terms of I and j, so we are going to write it in the I and j format, which is 14i plus 2j. For next question focuses on linear law. So here we have the non-linear equation and we have this linear graph from this equation. Alright, so in part A, we need to write out the linear form of this non-linear equation and using the clues inside this linear graph. Okay, so non-linear equation, change to the linear format using y equals to mx plus c, and we need to find the clues inside this diagram. So the only clue that we can find from this diagram is this -7 here, which is actually our y-intercept. Okay, and if we look at the non-linear equation, there is this -7 here. So this is actually our y-intercept. But now we need to remove this x cubed from it. So to remove it, very simple, divide the whole equation with x to the power of 3. Okay, and then we will get something like this, where you see that the y-intercept matches with the clues given in this diagram. And for part B, it says that we can form another linear equation according to this non-linear equation using the information in this table. And we need to express h in terms of k. Alright, so here again, non-linear equation, change to the linear equation, and let's find some clues from this table. So if we look at here, the value of x is 0, but y, there's a value. So this is actually the y-intercept. So for our c, it will be b. So according to the non-linear equation here, the b is here, and there's an x here. So what we need to do is to divide the whole equation with x. Okay? So you can see that now the y-intercept matches with the clues inside this table. Alright, so now we need to find the expression of h in terms of k. So what we are going to do is we can substitute the coordinates here and substitute into this equation. Okay, so the big X here will be h, which is the x squared. So x squared will be h, and the big Y is y over x. So big Y here is h over k. So this thing changes to h over k. But now the issue is the b here. Just now in this expression, it's only h and k, but there's no b inside. So what we need to do is to change the b to be either h or k. Alright, to express it in terms of h and k. So we have another coordinate that we haven't used, which is this one. So let's form another equation, but using the coordinates here. Okay, so the big X, we will be putting k, which is this x squared, and the b over 8, which is y, we will put inside this y over x. Okay, and then let us find the expression of b in terms of k. Right, so b here will be equals to 8k, and then I can substitute back into this equation and then find the expression of h. So everything which is h to the left side, and then I'm going to move this to the right side to find out the expression, and this would be our answer. Next question focuses on circular measure. So in this diagram, we have a semicircle, and in this semicircle, we have a sector inside, okay, this white color sector inside, and inside this sector, we have this right angle triangle. Okay, as you see, this is 90 degrees. Okay, and then they gave us another two clues. So the first clue is the sum of these two angles will be 30. So these two angles are actually here. Okay, And it also says that the radius of the semicircle and the sector are both 7 cm. Alright, so now in part A, we need to find out the angle of KQL in radians. Alright, so KQL is this part. Alright, so this one very simple, it's just 30 plus the right angle here, which is 30 plus 90, which is 120. And since this is in radians, we need to change it to the radian format. So we just need to multiply pi and divide with 180. So this pi, we need to change it to 3.142. Okay, so our answer would be 2.0947 radians. And make sure to put it in 4 decimal places. And for part B1, we need to find the perimeter of the shaded region. Okay, so this one will have a lot of lines, so I will start it at the outside first, then only go to the lines which are inside. Okay, so to find this perimeter of shaded region, we need to find the length of these lines. So from the outside, it would be line PR, arc PR, which is on the outside. Okay, and now I'm going to the inside, starting with point K. So here would be KQ, QM, MN, NQ, QL, and the arc of the sector, which is arc KL. Alright, so let us find the length for each of the lines here. So PR is the diameter of this semicircle, so it's 7 plus 7, so it's 14. And for arc PR is actually half of the circumference of this circle, so we are going to use the circumference formula, which is 2 pi r, and then I'm going to divide 2. Alright, so the circumference formula is 2 pi r, so r here is the radius, which is 7 cm. Okay, for KQ and QM, both of them are actually the radius of this sector, so both of them are 7. For MN, it is actually the hypotenuse of this right angle triangle, so the other two lines are actually the radius. Okay, this one is 7, this is also 7. So to find the hypotenuse, it would be 7 square plus 7 square, then square root. Alright, and NQ and QL are the radius of the sector, so both of them are 7. And for arc KL, this is the arc of the sector, so we need to use this formula. So we need to find the radius, which is 7, and the angle, the theta here is this angle, which is angle KQL, which we have found in part A just now, so we're going to multiply with this value. Okay, so once you sum up everything, then you will get the total perimeter, which is 88.56 cm. And for part 2, we need to find the area of the shaded region, so we can use the technique that we always use, big shape minus the small shape. So in this diagram, I think they help us to identify the shapes already, so this question would be simpler. Alright, so the big shape I would say is the semicircle. Alright, and then for the small shape, to remove these white color parts, I need to use the sector. Okay, but if I remove the sector already, I accidentally remove this part already, right, which is this triangle. So what I'm going to do is include the semicircle, remove the sector, and then I add back the triangle. Okay, so this would be the way how do we find the area of shaded region. Okay, so now let's find out the area of semicircle, which is simple. We can use the formula to find area of a circle, which is pi r square, and then this is a semicircle, so divide with 2. Okay, so the r here would be the radius of this semicircle, which is 7. And for the area of sector, we can use this formula, so minus 1 over 2, the r would be 7, and the theta here would be the answer in part A. Okay, and then for the area of triangle, because this triangle is a right angle triangle, so we can use the 1 over 2 times base times height formula. Right, so the base here is 7 and the height here is 7, so here will be 1 over 2 times 2 7s. Okay, and once you type this into calculator and simplify it, then you will get the area of the shaded region, which is 50.159 cm square. For our next question focuses on probability distributions, and in this part we are focusing on normal distributions, right? Because as you can see in part A, we are given this n. So n here refers to normal distribution, right? So for this part, we are going to sketch this normal distribution graph. So the first step here is to sketch our x-axis and y-axis here, okay, which is something like this. So please make sure to use a ruler, okay. And now we are going to draw the most crucial part, which is the curve, the normal distribution curve. So when we are drawing the normal distribution curve, make sure it is symmetric, right? Which means if I split this curve by half, left side and right side must have the same shape. Okay, so I think another thing students forget to do is to label the middle line. So the middle line is actually the mean of the distribution, which is 25. So we are going to label this 25 here. But why is the mean on the middle line of the curve? Right, reason is because mean again is the average of all the data. So meaning most of the data would be close to the mean. Okay, which is why as you see here, we draw the 25 at the peak of the curve because most of the data are close to 25, right? Which is why this middle line would be the mean, which would be 25. Okay, and for part B, we need to use back the same graph, and then we need to shape the part where x is greater than 35. Right, so let's shape it now. So 35 would be on the right side of this middle line because it's greater than 25. Right, so let me use the red pen, and we are going to draw the 35 here. Alright, and then here we are given the greater than sign, so this is like a sign that we are going to the right. So what we will do here is to sketch to the right side. Okay, and this would be our region. Okay, so now the second part is we need to calculate the probability according to this region. Okay, so to solve any kind of normal distribution question, we are going to use the 5S method to help us. Right, so the first S is to write out the statement, the probability statement, which we have already been given, which is this one. Okay, so we are going to use this. For the second S is to search our parameters, which is the mean and the standard deviation. Okay, but here this value is actually the variance because there is no square on top, right? Which means this value has been squared. Right? So if you want to find the standard deviation data, we need to square root this number. Okay? So now going to the third S, which is to standardize. So standardize meaning we are going to change the normal distribution to be standard normal distribution. Okay, to help us find the probability. So to change from x to z, we need to use this formula, which is x minus the mean divided with the standard deviation. Okay, so here the x value is 35, the mean is 25, and the standard deviation is square root of 39.69. Okay, so once we simplify, we will get this value. So now the fourth S is to sketch, which we have already done in the previous part just now. Okay, and for the fifth S, okay, so this one is to select the value from our normal distribution table, which we are going to see later, according to our shaded region. Right, but our shaded region need to satisfy these two criteria first. So the first criteria is it needs to be one-sided, which means our shaded region can only appear on the left side of the curve or the right side of the curve. Right? So now it's just right side of the curve, then we have satisfied the first criteria. And the second criteria is it can be sketched from the right end of the graph. Right? So means from the right end of the graph, which is here, I can sketch the area also, right? Because it is connected from the right end. Okay, so we have also satisfied the second criteria. So this shaded region is eligible, and we are going to use this z value to find the probability using the normal distribution table. So to find the probability, we need to match the 4 digits according to these 3 sections. Okay, so for the first 2 digits, we are going to look at section A. So 1.5 is here, so means we are going to look at this row. Alright, the third digit is 8, and we are going to look at section B. So 8 is here, and we are going to look at this column. So here we can already found a value, which is 0.0571. Alright, and don't forget the last digit. Okay, so this one we're going to look at section C. So this is 7, so we are going to look at this column, but the same row. So here would be 8. So what does the 8 do here? So this is the second step, which is to minus. So meaning we are going to use the value here and minus with 8. But this 8 is not 8 here. It's actually starting from the back. So this value of 8 is 0.0008. Alright, so we are going to use this value to minus with this value, so we can get the probability, which is 0.0563. Alright, so this will be our probability. For next question, we are still in the same chapter. It's just for this situation, we are not really sure is it following the binomial distribution or the normal distribution. Okay, so let's go through this paragraph. So here there are a lot of things to digest, so let me help you all summarize it. Okay, so they are in this competition, and this competition have checkpoints. Okay, so let me use rectangles as a checkpoint. Okay, so in each checkpoint there would be 5 tasks. Okay, and if we successfully complete at least 4 tasks and above, we are going to get a coupon. Okay, and it also says that for each task, the probability of success is 0.75, which means 75% successful rate. So now in part A, we need to find the probability where this team can get the coupon, can get 1 coupon. So this means to get a coupon, it depends on the number of successful tasks, right? So if we want to find this probability, we can look at the situation of each individual task. So for each individual task, there would be only 2 outcomes, right? Either you succeed or you fail. So recall back the things we have learned in this chapter. For experiments which has only 2 outcomes, for example, heads or tails, all of these experiments will follow the binomial distribution. Okay, so this question uses the binomial distribution. Alright, so now to set our x, right, our unknown, we can focus on the number of successful tasks. We are not gonna follow the number of failed tasks, because here in this question it only focuses on the success tasks. Okay, so x value will be number of successful tasks. So now this value of x follows the binomial distribution, and we need to set the 2 parameters here. So the first parameter is the number of trials. So the number of trials to get this coupon would be according to the number of tasks here, right? So here if we have 5 tasks, we have 5 opportunities to get this coupon. So our number of trials would be 5. Okay, and the probability of success would be the probability that we can get a successful task, which is this one, 0.75. So now with these two parameters, we can find the probability where the team is eligible for one coupon. Okay, so if you look back here, the criteria is at these 4 tasks. Alright, so our probability would be where x is greater than or equal to 4. Alright, and then we're gonna look at the cases that satisfy this criteria. So there are 2 actually. So the first case would be we successfully complete 4 tasks, so it's x equals to 4. And another case is we successfully complete all the tasks, so means all 5 of them. Okay, so to find this probability, we need to calculate the probabilities for these 2 cases. So to find the probability, we can use the formula lah. Okay, so we are going to substitute all the information that we have inside here. Alright, so n will be 5, and the value of r here will be according to the red values here. The value of p will be 0.75, and here will be according to the red values. And the q is the probability of failure, so it will be 1 minus this value lah, which is 0.25. And here it's n minus r, so according to the first one is 5 minus 4, so here it's 1, 5 minus 5, here it's 0. So we add up these 2 values, we will get the probability. Alright, for part B, there's a lot of information also, so let me help you summarize. So in total, this competition, we have 6 checkpoints. Okay, and of course for each checkpoint, we can get a coupon or not get a coupon lah, according to the number of successful tasks. Alright, and it says that if we get more than 4 coupons, for example here we have 1, 2, 3, 4, 5, so if it's more than that, we can get this mystery prize. So the question now asks us to find the probability where we can get this mystery prize. Alright, so this prize is following the number of coupons, right? Number of coupons that we have, then we can determine whether we can get the prize or not. But now it's not following the number of successful tasks, right? So in this part B, we cannot use the distribution in part A, so we need to set another new one. Okay, so since the price depends on the number of coupons, so we're going to focus on the coupons now. So coupons, there will only be 2 outcomes. Either you get it or you don't get it, right? So this also follows the binomial distribution. So here we can set another unknown, let's say is y. So for y, we are going to focus on the number of coupons that we can get. Okay, that we can get. So since this y follows the binomial distribution, we are going to find the 2 parameters again. So the number of trials to get this prize would be the 6 checkpoints here, right? Because for each checkpoint, either you can get a coupon or not get a coupon. So we have 6 tries to get this prize. So here will be 6. And now the probability of success. So this one is the probability that we can get a coupon, which is the answer in part A, right? Because this one is the probability whether we can get 1 coupon or not. So we are going to use the answer in part A as our probability of success. Okay, so this is a bit mind-blowing, right? But this case might happen and might happen in SPM also. Okay, so please take note of this. Alright, so now to find the probability to get this mystery prize, the criteria is more than 4 coupons. So our probability would be y greater than 4. And similar to part A, we are going to find all the cases where y is greater than 4. So there will be 2 also. So the first case is this one. In 5 checkpoints, we got 5 coupons. Or either from 6 checkpoints, we have all the coupons from all the checkpoints. So here will be y equals to 6. Okay, so we are going to use this formula again and to find the probability. Alright, so here the value of n is 6 now, and for the r we are going to use the red colored values here, and for P would be 0.6328, and the power here according to the red values here. And for the Q, so Q will be the probability of failure, so 1 minus this value. Okay, and the value for the power, it would be n minus r, so 6 minus 5 is 1, 6 minus 6 is 0. And once you simplify this, you can get the probability, 0.2878. Question 10 focuses on permutations and combinations, and in part A, we need to arrange these 6 digits. Okay, so here there are a lot of conditions here, so let's go through one by one. Alright, so the first condition is without repetition, which means we cannot use the same digit again. So for example, you used 2 already, you cannot use back 2 again. Alright, the second condition is we need to form a 4-digit number. Okay, so from the 6 digits here, I can only choose 4 out. So each blank space here is 1 digit. Okay, and then the next condition is it must be an odd number. So means for the last space here, I can only put the odd numbers, which is 1, 3, and 5. Okay, and the last condition here is larger than 5,000. So means for the first blank space here, I can only put 5 or 6. Right? Because the values which has the first digit, which is 5 or 6, will be confirmed larger than 5,000. Alright? So now we need to, based on these conditions, to find out the number of arrangements. Okay, so for the values that we have set here, so why not we list down all the possible cases according to these numbers here. Right? So either we can put 5 and we put 1 here. So this is our first case. The second case can be I put 5 here and I put 3 here. Okay, but for the next one, if I put 5 here, I cannot put 5 again because one of the conditions is without repetitions. So I cannot do that. So we'll skip that one. So now let's say if we put 6 here and we put 1 here, so this would be my third case. And if I put 6 here, 3 here, will be the fourth case. If I put 6 here, 5 here, there will be the fifth case. So here we have in total 5 cases. Okay, so for answer, let us put a 5 first. Right, so this is for the first and the fourth blank space. So now we're gonna focus on the middle two. So so let me use this case as example. So now we have used 5 and 1. So means we have 4 digits left. So what I'm going to do is, from the 4 digits here, I'm going to choose 2 here and we're going to arrange them. So this one is technically 4p2. From 4 digits, I choose 2 to arrange. Okay, so we're going to use this and multiply with the 5 here to get our answer, which is 60. And for part B, we have these 2 lines. So the first line we have 4 points, the second line we have 5 points, and from these points we need to find out the number of quadrilaterals that can be formed. Okay, so to form a quadrilateral, the condition is we need to choose 2 points on this line and 2 points on this line, right? So now to find different quadrilaterals, we need to use this condition, and we can use C to help us, the combination to help us. Because here we are just choosing points, we are not arranging the points. Okay, so to find the number of different quadrilaterals, so here will be 4 points, choose 2. So here will be 4C2, and here we have 5 points, we choose 2. So here we need to multiply 5C2, and then you can get the different quadrilaterals that can be formed, which is 60. Okay, and for the second part is triangles. So triangles, we have 2 cases. Okay, the first case is we choose 1 point from the first line and 2 points from the second line. Right, so to use the combination method, it would be 4C1, from 4 points choose 1, and from the second line would be 5 points choose 2, so it's 5C2. Okay, so this would be the first case. The second case can be the other way around, which is the first line I choose 2 points, so here will be 4C2, and for the second line, from 5 points I choose 1 point only, so here is 5C1. Okay, so I simplify this, then I can get the number of different triangles that can be formed, which is 70. And for question 11, we are coming back to the Indices, Surds and Logarithms chapter. So now we are focusing on surds. As you see here, we have the square root. Okay, so now in this question, it gives us this prism and it says that the area of this triangle is this. Okay, and it also says that we have another cylindrical tank with radius r and height 6 cm contains this amount of water. Alright, so now it says that if this prism is put into the cylinder, it will be fully filled. Alright, so now we need to find the value of r according to this form. Right, so let's write out an equation according to this question first. So we can use this sentence actually. It says that the cylindrical tank would be fully filled if the prism and the water is inside the cylindrical tank. So we can use the volume to form the equation. So here means the volume of the cylindrical tank would be equal to the volume of this prism plus the water inside it. Okay, so we are going to use this equation to find the value of r. So now let us find the volume of the cylinder, the prism and the water. So the cylinder's volume would be using this formula, pi r square h. So pi would be pi, the radius would be r, the height would be 6. Right? And the prism here, we can use the area given here. So this is the area of this triangle, and to find the volume, just multiply 3. This is the height. Okay, so these two values multiply together to get the volume, and for the water, we have already been given. Okay, so before we move on, you will see that the values inside the square root, there is 2 and there is 8. Okay, but in the question, it tells us to write it in square root 2. So for the square root head here, no matter how, we still need to change it. Okay, so what I will do is, I will need to make sure that the square root inside must have 2. Okay, so means I need to take out a value from 8 already lah. So if 8 divided by 2 is 4, right? So I'm going to take out 4, and I'm going to take this 4 out of the square root. So if I take square root 4, sorry, I take 4 out of the square root, then it will be 2, right? Because square root 4 is 2. Okay, so this one will disappear, and it will be 2 square root 2. Okay, so this square root 8 will be this one, and I'm going to multiply with 3, so here will be 6 square root 2. Alright, so now with the values that has r, because we are finding the value of r, I'm going to move them to the left side. Okay, so because both of them have pi r square, so I can just combine their values. Alright, and now I'm going to move this to the right side, and since both left and right have pi, I can cross it off also. So it will be something like this. Okay, so now we have a situation where the numerator and the denominator have square roots. So now to simplify this even further, we need to remove the square root at the denominator. So the common way to do this is to multiply the conjugate. Right? So this is called the conjugate. So conjugate is technically using the other version of this value and multiply it, so we can remove the square root. So this one is the negative version, right? You can see here is the negative, so I'm going to multiply using the positive version. Okay, so you will see here that is positive or plus here. Okay, so now to simplify further, I'm going to cross multiply the values in the numerator and the denominator, and then once I simplify, you will get this. Okay, so this 18 I'm going to divide with these two values here to get this result. Alright, and for the square here, I'm going to move it to the other side. So here we need to put a square root. But you will notice that when we move the square, we don't have plus and minus here. The reason is because radius cannot be negative, because it's a length, right? Radius is a length, so it cannot be negative. So I'm just ignore the negative and I'm just going to remain the positive answer. Alright, and this will be our answer. And before we go to the next question, I just want to clarify the steps from here to here because I feel it's a bit too fast. So let me show you the result when we cross multiply these two values. Okay, so for the two middle values here, it's not here, as you realize, because this 18 square root 2 is where we multiply these two values, and this negative 18 square root 2 is where we multiply these two values. So now you see these two values are actually the same, but one is positive and one is negative. So this one, they will cancel off each other. That's why it's not here. Okay, and then you will see for this one, we are multiplying two square root 2's. So if you're multiplying the square root which have the same number, at the end it will be just a number. So here there will be just 2. So now you see in the denominator, the square roots are removed. So this is the purpose of multiplying the conjugate. Alright? For question 12 focuses on progressions. Alright, so here we have this person swinging, and here it says for the first swing, the distance traveled is q meters. So means A is q, right? A is the first term. And here it says that the distance traveled by the swing is 10% less than the previous swing. So means if you want to find the next swing, we need to multiply 90%. Right? We need to multiply 90% because 10% is lost. So the remaining is 90%. And since we are multiplying to get the next number, this means that this progression is a geometric progression. So this 90% is actually our R. Okay, but I'm going to change it to decimal, so it's 0.9. Alright? And here it says that the distance traveled during the nth swing, okay, just focusing on the nth swing, is 324. So this is actually Tn. Alright, which is 324. And it says that the total distance of the first n swings, okay, this is total and the first n swings, so this is Sn, and the value is 1084. So now we need to find the value of q and n. Okay, so since we have the Tn and Sn already, so means we need to use the formula already lah. Okay, so let's start off with Tn first. So Tn would be A is q, and R is 0.9, and here n minus 1. Okay, and the Tn we are going to substitute this value, which is 324. So what we can do is let us simplify it to the simplest form. So what I'm going to do is I'm going to split the power here. So this is negative, and if we split the power, means we are going to divide with the value. We're going to divide 0.9. Okay, as you see here. So now this 0.9, I'm going to move it to the left side, and I think that's all that we can simplify for now. Alright, so let's go to Sn. So here we have two formulas, and the criteria to use either of these formulas will be based on the modulus R value. So if it's more than 1, it will be using the first formula. If it's modulus R less than 1, we will use this formula. So now if we modulus this value, it's 0.9, so it is less than 1, so we are going to use this formula. Okay, so Sn will be equal to A, which is Q, and 1 minus Rn, so our R is 0.9, and the denominator is 1 minus 0.9. Okay, and then I'm going to substitute Sn here. So now I'm going to multiply 0.1, sorry, move this 0.1 to the other side, so it's multiplying. Okay, and then that's all we can simplify for now. Alright, so now with these two equations, you can see that it's q and n, right? But how do we simplify even further? Okay, that's the question. Alright, so the way that I look at this, right, is looking at the 0.9 here actually. Because as you see, these two are actually the same. So why not we use the substitution method? We are going to put this on the left side and rearrange this equation and substitute it into here to find the value of q instead of n. Because now n is at the power part, which will be a bit hard to find out the value. Okay, so what I'm going to do is 0.9 power of n, move on the left side, and everything which is not that, move to the right side, and then substituted here. So you can see everything here is now q. Okay, which will be easy for us when we simplify it, and we can straight find the value of q already, which is 400. Alright, I'm going to stop y'all there because this 400, we need to look at the unit first. Okay, so in Tn and Sn, we used cm. But q is the only thing that uses meter. So if we want to find the value of q, we need to change it to meter lah. Okay, so this 400 technically is cm, so to change it to m, we are going to divide with 100. Okay, so now finding the value of n, right? Okay, this value of q, we cannot use 4 because this Tn, we already used the cm unit. So to substitute the value here, we are going to use the cm version. Alright, so this q will be 400. Okay, so now to find the value of n, we divide these two values. And here, technically, right, this 0.729 is actually 0.9 to the power of 3. Okay, so what we can do is we compare the powers. So here, n would be 3. Okay, so if you can't really think of this right, there's another way, which is to apply log for both sides. Okay, this is also another way. So the n, I'm going to move it to the front, okay, because it's one of the formulas that we used in the previous question just now. Alright, so this log 0.9, I'm going to move it to the other side. So it would be something like this. Okay, and once you type this into calculator, you can also get n is equals to 3. Okay, so there can be more than one way to do this. For part B, it says we need to find the number of swings. So number of swings is the value of n when the distance traveled by the swing is less than 2 meters for the first time. Okay, so this distance traveled by the swing is that swing itself. It's just that swing. It's not the for example this one, the total distance for the first n swings. Okay, this one we use as n, but because of the swing itself only, we are going to use the Tn formula. Okay, so this would be Tn. So now to find the value of n, we need to use the inequality where Tn is less than 2. Okay, so we are going to use this. So we are going to use back the formula of Tn. So A here, I'm going to use the meter version, not the cm version, because here we are given meters. Okay, so the value of A is 4, and the value of R here will remain as 0.9. Okay, so I'm going to move forward to the other side. So now you can see that the value of n is at the power part. We need to have a way to move it down. So the only way to move it down is to apply log for both sides. Okay, so the value of n minus 1 can be here. So now things which are log n need to move it to the right side. So this log 0.9, I'm going to move it to the right side, and you will see that the sign has changed. Okay, reason is because for the log values which is less than 1, all of them are negative. So if we move negative values to the other side, we need to change the sign. Okay, So you can try out to put this into calculator. You will see that it is a negative value. Okay, so now I'm going to move -1 to the other side, and now this value of n is a number of swings, so it must be an integer. Okay, so it means we need to find the smallest integer which is larger than this value, which is 8. Okay, so once it reaches the 8th swing, then the distance traveled is less than 2 meters. And for part C, we need to find the total distance traveled before the swing stops. So the question is, in which swing does the swing stop? So what is the value of n? So if we imagine this situation, right, where the girl starts to stop, okay, the number of swings when she starts to stop, right, it's very hard to calculate because the movement is very small. So means we are unable to find the value of n. The value of n is unknown. So to find total distance traveled where the n is unknown, we can use a less known formula in geometric progression, and I hope you'll remember it's this one, the sum to infinity formula. So we will use this formula when we don't know the value of n, but we want to find the total distance traveled. Okay, so to find the answer, very simple, we are just going to substitute the value of a and r from here, and we can find the answer, which is 40 meters. So now we are going into section B, and this is the first question which comes from chapter Trigo functions. Okay, so if you're not really familiar with Trigo functions, I actually made some videos which really focus on this chapter. So I will put one of their links here, which will pop up now. Okay, so you can click into it if you are interested. Okay, so I will be sharing some tips and tricks on Trigo functions, and I will be using the 2023 trial paper questions as examples. Alright, so if you're interested, you all can click into it now. Okay, so now coming back to here, part A, we need to solve this Trigo equation. Okay, so to solve Trigo equation, usually what I will do is to change the Trigo functions to be either sine or cos. Alright, because sine and cos we are more familiar. Okay, so for the secant, it's the inverse of cos, so here will be 1 over cos and this value. Alright, so now I want the left side to be just cos only, so I would be changing the places of 2 and the cos, okay, and then switch their places, so it will be something like this. Alright, so now to simplify further, what we will do is to move cos to the other side. So moving it to the other side will be something like this. Okay, so we are going to find this value, okay, which is 60. But again, for Trigo equations, for each equation there will be 2 answers. Alright, so if you want to find the 2 answers, we need to use the ASTC way. Okay, ASTC way, add sugar to coffee. Alright, so now since cos here is positive, so we are going to look at these 2 quadrants. Right, the first quadrant, which the answer will be theta, and the fourth quadrant, which the answer will be 360 degrees minus theta. So this theta would be this value, and this value is actually 60. So one of our answers is 60, and the other one will be 360 minus 60, okay, which will be 300. So now we have found our 2 answers, but here I would like you all to focus on the 2 theta here. Alright, so what does this 2 theta mean? So let us focus on theta first. So theta here, if you look back at the question, it says from 0 until 360. So for theta means it is 1 cycle. Okay, from 0 until 360, 1 cycle. So 2 theta will be 2 cycles. Okay, so for 360, I go another round and reach 720 degrees. Okay, because 360 plus 360. So now if I apply the ASTC back here, so quadrant A would be here, quadrant C would be here. So if you notice, this line passes through this quadrant, quadrant A, at 2 times, right? 1 time, and then 2 times. Quadrant C, same thing as well. 1 time, and then 2 times. Okay, so this means if the number of times that passes through these 2 quadrants is 4, so means I need to find out 4 answers. Alright, so means 2 is not enough, we need 4. So how do we find the other 2 answers? Okay, it's just very simple. So this 60 is actually, let's say it's just located here. Right? So if we turn one round and go back to the exact same point, technically it's just adding another 360 because we turn another round. Okay, so for this 60, we are just going to add 360 to get the next number. Same goes to 300 as well. Right? So it would be 660. Okay, so what we need to do is just add 360 degrees. Okay, so once we found our 4 answers, then we can just move the things which are not theta on the left side to the right side. Okay, so for example, this negative 70 move to the right side means we are going to add 70 for all of the answers here. Alright, and then for the 2, I'm going to move to the right side, so means divide all the angles here with 2. So this would be our answers, but if we check back the angle of theta, it must be from 0 until 360, so the last value we have exceeded, so we need to exclude this from our answer. Alright, so our theta value will be these 3. But before we're going into part B, right, this question is actually quite sticky. Okay, so I would like to let you all know something first. So for the 2 theta here, just now we have said that if 2 theta means 2 cycles and intersect or pass through 4 times, so there will be 4 answers, right? So if it's just theta, it will be just 2, right? If it's 3 theta, it will be 6 answers. Okay, so now if we look here, 2 theta, we have only have 3 answers, which is not tally with here. So means we are missing out 1 answer. So we need to figure out that answer. So if here we rejected 1 of the answers, this means we need to consider the negative version of these angles. So what does the negative version mean? So for example 60, it will be negative 60. For 300, it will be negative 300. Okay? So now, which are the negative versions of these answers we need to include? Right? So usually I would take the closest value lah, the one which is closest to 0. Okay? Because we have 1 answer missing, so we are going to use the nearest one and we are just going to ignore the others. Okay, so this is actually our missed out angle. And now, if we want to include this as our answer, we need to use back apply back these things lah, which is plus the 70 and then divide by 2. Okay, so once we add 70, it will be 10. And once we divide 2, it will be 5 degrees. So you see, once I change everything, this 5 is actually inside this range. Okay, so this is actually one of our answers that we missed out. Right, so in total, there will be 4 answers. Because here, 2 theta. 2 theta means we need to have 4 answers. So if you are missing 1, we need to look back at our negative version of our answers. And usually we will find the value which is close to 0 lah. Don't want to choose these very big negative values. Alright? So now let's go to part B. So we need to derive the identity of this trigo equation. Okay, which means we need to prove this equation lah. Okay, so if you realize this equation is actually one of the formulas in the formula sheet, which is this one. Okay, so they're telling us to prove an formula from the formula sheet. Okay, so this one no need to panic because there is actually a way to prove this. Alright, so this 2 theta, what we can do is to split it up. So means theta plus theta. And from our formula sheet, there is one of the formulas which uses theta plus theta, which is this one. Right? Cos A plus or minus B. So now our A and B are both theta. Okay, so why not we use this formula to help us prove this formula. Okay, so we are going to use cos 2 theta, and we're going to split the thetas out, and we're going to use this formula. So here will be cos theta, and here it's positive, so means we need to use negative, okay, because negative is on the top, and we are going to put sin theta. Alright, so here we have 2 cos theta, so we multiply them, will become cos square theta, and this one will become sin square theta. Okay, but now it still doesn't tally here, and we only have 1 sin square theta, here have 2, so which is the other formula that we need to use here? Okay, if you remember correctly, there is also another formula which uses sin square theta and cos square theta, which is this one. Right? So since the equation that we need to prove doesn't have cos square theta, so we're going to change this. So what we are going to do is, for the sin square theta here, because now we're using theta, I am going to move it to the right side. So this cos square theta, I am going to change it to 1 minus sin square theta. Okay? To be changed to 1 minus sin square theta. Okay, so once I simplify this, then I can get the result that we are trying to prove here, right? Which is 1 minus 2 sin square theta. So just to let you know, for the formulas for cos 2 theta, right, all of these can be found using these 2 formulas, right, using the same technique. So for example, this one, right, cos square theta minus sin square theta actually is one of our working. So once you have used this formula, then you can find this one already. Okay, but for these two will be a bit complex because we need to use this formula. To change one of the functions, for example, cos change to sine, or sine change to cos. Okay, so to change, we need to use this formula lah. Okay, so this one is just an FYI for you all. And for the last part, we have this question. So here we are given these 2 clues, which is tan theta is given a value and theta is between this range. So usually when I look at these 2 clues, my mindset is I need to draw a triangle according to these 2 conditions. Alright, so for our theta is from 90 degrees to 180 degrees. So from this graph, the angles here would be here, 90 degrees is here, 180 is here, so I'm going to draw my triangle on the quadrant here, which is the second quadrant. Okay, and now we can label our angle, this theta here, and now we need to find the length of these 3 sides. Okay, so to find the length, we can use this information, because we know that for tan, it's opposite divided by adjacent. So we can compare this with the value given here. Okay, so for the opposite, it would be 1. Okay, so opposite is the opposite of this angle, which is here. So why is it not negative 1? Because there's a negative here. Alright, so a tip for y'all is I will view this as the x and y axis graph. Okay, even though it's not, but I will let y'all to imagine that this is a x and y axis graph. So for the values here, right, okay, the values on the y axis, these are all positive values, which is why this is a positive value. It's not a negative value. So if you look at adjacent, right, adjacent, if we compare, it's p, but here I will put negative p, because if I look at the values on the x-axis, right, these values are all negative because it is at the left side of the y-axis Okay, so this one would be negative. So this one I would say is a quite common mistake for students because they forgot to put the negative, and maybe they accidentally put negative to the wrong side. Okay, so a tip for you is to view this into the x and y axis graph, so you won't do any mistakes after this. Okay, alright, so now we need to find the length of this side, and this is actually a right angle triangle, so we can use the Pythagoras theorem to help us. Alright, so 1 square plus the square of this value, and we square root it, then we can get the length. Okay, so now we can go to part 1 and part 2. So part 1 is cosecant 2 theta. So the first step is always change the functions to be sine or cos, because these two are which we are more familiar with. Okay, so cosecant is the inverse of sine, so here will be 1 over sine 2 theta. And for the 2 theta here, I would recommend to change to theta first, because our angle here is theta. The angle in this diagram is theta, so I'm going to change all the weird thetas to be just theta only. Okay, so we have a formula to change sine 2 theta, which is this one, okay, which is 2 sine theta cos theta. So now you can see all are theta. Okay, so now to find the value of sine theta and cos theta, we can look back at this triangle. Okay, so sine theta is opposite divided by hypotenuse, so it's 1 divided by this square root. Okay, and for cos theta is adjacent, which is negative p divided with the hypotenuse, which is this square root. Okay, and then now we just simplify this. So the numerator part will be negative 2p, and then the denominator part, because we are multiplying the same value and both of them have square root, so once we multiply them, the square root will disappear. So we are left with 1 plus p squared. And now this value is actually the denominator part, so we can move this fraction above to the numerator part, so means we are going to flip their places, so means 1 plus p squared is on top, 2p is at the bottom, and don't forget the negative. Alright, so this will be our answer. And for part 2 we have this. Okay, so since there are 2 angles here, we can use the formula for sine, which is the a plus b1, which is this one. Okay, we have 2 angles inside the bracket, so we can use this formula. Alright, so let's go one by one. So a will be theta, b will be 90 degrees, so here will be sine theta cos 90 degrees, and this one is minus, it's at the bottom, so we are going to use the sign at the bottom, which is negative. Alright, so negative cos theta and sine b, which is 90 degrees. Okay, so sine theta we can use back the value that we have used in part 1, which is this one. Okay, for cos 90, this one we can put it into calculator or you can draw the graph lah. Alright, so both ways you will find that the value is 0. Okay, according to the graph, this is 0. So cos theta is 0, and for cos theta we can use this result. And for sine 90 degrees, if you put in calculator, it's 1. Okay, so this is 0, so we can just ignore this part. Okay, just ignore this part. So our answer is just this. Okay, and this will be our answer. So you don't have to worry that the square root is at the denominator part. So for this type of question, for this chapter, this is accepted. Okay, so you don't have to do anything. Alright. Question 14 focuses on quadratic functions. So let us understand this graph a bit. So here we have this function. Okay, and then here we see that this curve actually intersects the x-axis at 2 points, which is m and n. And we have the axis of symmetry of this curve, which is x equals to 1 over 4. So again, axis of symmetry is the middle line of the curve. Alright. And this axis of symmetry actually provides the x coordinate of the maximum point. Okay, so the maximum point of the x coordinate of the maximum point is 1 over 4. Right, so now in part A, we need to find the range of values of q in terms of p. So q and p are actually in the quadratic function. Alright, and range of value means that our answer needs to have inequalities. So how can we relate inequalities q and p? Right, so let's recall back all the knowledge that we have learned in this chapter. So the only one that uses inequalities is actually the discriminant. So what we can do is, because this value a, b and c are from the function, so we can sub q and p inside, and from the 3 conditions here, 2 of them have inequalities. So we can form an inequality with q and p inside using the b squared negative 4ac knowledge that we have learned. Okay, so now for which one that we need to choose, we need to look at the diagram here. Okay, so we see that this curve intersects the x-axis at 2 points. So means from these 3 conditions, we need to use this one. Okay, because this one, the graph will intersect the x-axis at 2 points. This one is just 1 point. This one doesn't intersect at all. So we are going to use this information. Alright, and then we are going to form the inequality and relating q and p. Alright, so the value of b here will be the value of x, which is 1, value of a, which is the value of x squared, which is p, and value of c would be the value given here, which doesn't have x, so it's negative q. And now we are going to move everything which is not q to the right side, because here q in terms of p. Right, so once I move everything, this will be our answer. But to let you all know, the answer scheme for this question is wrong, I would say, because we don't have to change the sign actually. Okay, if you look at here, this negative and this negative will be together and then will be positive. So the q here is positive. The 1 here, I will be moving it to the right side, but this one is not dividing. This one is minusing. We minus 1, and so to move this one to the other side. We are not dividing, we are minusing. Why we minus is because this 1 square can cancel off this 1, so this 1 will appear here, but it will become negative lah. But this one doesn't affect the sign because we are just minusing, we are not dividing. Okay, so which is why the sign should be greater than. Alright, part B. So this is the question where I need to use answer scheme and then only able to know how to prove this equation. Okay, so now let's assume that ourselves, we are at the exam hall, we don't have the answer sheet, so how do we solve this question? Okay, so now I would like you all to use a technique in the Trigo functions chapter for proving equations. Okay, so for proving equations, we have learned this technique, which is we are going to select the more complex side of the equation to prove the less complex side. Okay, so we can apply this here. So here I would say this is the more complex side, so what we will do is use the left side to prove the right side. Okay, so that's that. And now if we look at the unknowns in this equation, we have m and n, which are the roots of this curve, and we have q. So q is the value from the function. So the question is, how do we relate the roots and the numbers of this function? Okay, so let us recall back the things we have learned in this chapter. So one of the things that we have learned for roots is we can find the sum of roots and the product of roots from the function here. Okay, so this is the information that can relate the roots and the function. Okay, so let's find out the SOR and POR first, right, from the function. So the first thing to find SOR and POR is to make sure the value of x squared is 1. Okay, as you see here, there's no value here, there's only 1. So here, we need to divide the whole equation with p. Okay, and then we can find the SOR and POR. So according to this diagram, the SOR here would be m plus n, right? So m plus n would be equal to this value. Okay, but this is another thing I need y'all to memorize, which is when we extract the SOR, if it's positive here, when we extract, we must change it to negative. We must change the sign. So means if it's negative, then we should put it to positive. If it's positive, then we put it to negative. Okay? And for POR, it's much straightforward. Okay, so in this diagram, it's m times n, and then will be equal to this value. Alright, so it's simple. And there's another information that we can extract from this diagram. So just now I've mentioned that the axis of symmetry here is the middle line of the curve, right? So if this is the middle line, this means that this point 1/4, it is actually the average of these two values, right? Because this curve is symmetric, left side, right side have the same shape. So if I add up and divide with these two values, then it will be 1/4. Okay, so we can form another equation on this. Alright, and then we simplify. You will notice that this one and this one actually both are n plus n. So here, if we compare the values, we have already found the value of p. Okay, so value of p here would be -2. Okay, so now once we have all our information ready, then we can start to prove the left side to the right side. Okay, so the first thing that we need to do is to change it to the same denominator. Alright, and it will be something like this. So now, if we look at the denominator, this mn, we can change it to this one, right? Because we have mn here as well. But how about n squared plus n squared? We don't have m squared plus n squared here. Alright, so this one we need to take out one of the earliest things we have learned in mathematics, okay, which is this equation. So we know that a plus b squared is equals to this. Okay, so this result is once we expand it lah. Alright, so let me change the values of a and b to be m and n. Okay, so now you see m squared and n squared are actually here. So what we are going to do is we change the m squared plus n squared here, because there's no m squared plus n squared here, right? So what we are going to do is form an equation by putting m squared and n squared on one of the sides. Okay, so means this 2mn, I'm going to move it to the left side. So this m squared plus n squared can be equal to this. Right, so why I changed to these two things? Because this m plus n is actually here. This mn is here. So all of the m and n here, we can change it to p and q already. Alright, so the m plus n here will become -1/p, mn will become -q over p. Right, and since we have found the value of p already, so I can just substitute it here. Okay, so why I substitute here is because if you notice, this equation doesn't have p. So this p needs to be changed to be number. Alright, so it's -2. So once we simplify everything, then we can get the result on the right hand side. And the last part, we need to use the completing the square method to find the maximum value of this f of x. Okay, so now recall back the vertex form. The maximum value would be the value k. right? So we need to find out this value. Okay, so to use the completing the square method, we have three main steps. So the first step is to factorize. We are going to factorize the value of x squared, which is minus 2, from the values that has x, okay, which is these two. So means these two values I'm going to divide with negative 2. Okay, so it will be something like this, and the minus q here I can just remain in. Alright. The second step is to divide and square. So I'm going to use the value of x, which is negative 1 over 2, divide with 2, and then square. But since we are adding a value, we need to minus the exact same value, okay? Because we want to balance the equation. Okay, when we add something, we need to minus something. Alright, so yep, this will be the result, and then the minus q will remain. And the third step here is to combine the first three values. Okay, combine the first three values that has square, which is this one and this one. So here will be x, and the simplified value here will be negative 1 over 4. Alright, and this one you will just simplify as usual, then you will get negative 1 over 16. So now this negative 2 I'm going to multiply inside the bracket. Alright, so this would be the result. So now we are finding the value of k, so value of k would be this one. Okay, so our maximum value would be 1 over 8 minus q. Alright, and just to let you know, the answer scheme is also a bit incorrect because the value of q for some reason is positive. I think they forgot to change the negative, so the true answer should be 1 over 8 negative q, not positive q. Alright? And the last question comes from coordinate geometry. So here we have the coordinates of these two villages. Alright, and there is this road here. And for this sentence, I will skip it first because it's more important for part B. Okay, so we're going to part A first. So here it says another straight road will be connecting these two kampong. Alright, and then it says that distance between these two kampong is 2 square root 10. So now we need to find the value of h. So h is the x coordinate of kampong B. So since it gave us the distance of these two kampong, so what we can do to find h is to use the distance formula. So we are going to gather all of the information that we have, substitute into that formula, and find the value of h. Okay, so for distance formula, very easy. What we need to do is to find the differences between the two x coordinates first. Alright, and then find the difference between the two y coordinates. And then we are going to square them, add them up together, and then square root. Okay, so this is using the distance formula. So now they gave us the distance already. So on the right side, we're going to put equals to the distance, 2 square root 10. Right, so now what we are going to do is we need to remove the square root. So what we should do is to square both sides. Alright, so for the left side, if we square, this square root will cancel off with the square here, and then this square it is going to be applied to these two numbers. So 2 square will be 4, and this square root 10, the square root will cancel off with the square. So this would be the result that we will get. So for the left side, I have simplified them and squared them. So the final result will be something like this, and this one will be 4 times 10. Alright, so now I'm going to move everything to the left side, and we will get a quadratic equation. So with this quadratic equation, we can factorize it, and using calculator, find the two h values, which is h equals to 2 and h equals to minus 10. So to see which one to select, we are going to look at this diagram. So according to the diagram here, village B's x coordinate should be somewhere here. Okay, so this value of x is positive, so we are going to accept h equals to 2 as our answer because it's positive. So we are going to reject this one. So before we go into part B, I would like to explain this sentence first, right? So here it says that in any point of this road, right? So let's say I choose here, the distance of this red point to village A, okay, which is this one, and the distance of this red point to village B is the same, right? In any point of this road. So for example, this one, the distance of this red point to village A and the distance of this red point to village B is the same. So any point in this road, they will satisfy this condition. So in this chapter, we have learned that for points which satisfy a condition, these are called the locus. Alright, so we can use the locus way to solve this question. Alright, so in part B, it says that we need to use the value of h from part A, which is 2, and they gave us this clue where this city C is at this road. Alright, so let me assume that this red point is point C, and these are the coordinates K and P. So now we need to express K in terms of P. So to do this, we can use the locus way. So locus, we have two cases, right? One is one fixed point and the other one is two fixed points. So now our two fixed points would be the coordinates of these two villages. So we're going to use this formula to help us. Right? But just a note that this formula will not be given in the SPM formula sheet. So this one, I would advise you all to understand the formula instead of memorizing it. Okay, so if you look at here, these are all the distance formulas, right? But how do we understand it overall? Okay, so let us focus on the numerator part first. Alright, so the numerator part is focusing on one of the fixed point first. So let's say I choose the point for village A. Okay, the point, so this is our first fixed point. Okay, so what we are going to do, very simple, is just finding the distance of the red point with the village A coordinates. Right, so I'm going to find the distance of find the differences of the x coordinates and the differences of the y coordinates, square them, add them up together, and square root to find the distance. Okay, so for the right side, we would write out the distance. But here it says the distance is the same, so I can just put any number that I want. So the most simplest number is 1. Okay, so I'm going to assume that the distance from this red point to village A is 1. Okay, so if I put here 1, means that for the other fixed point, I need to put 1 also. Okay, so now this is for the numerator part. So for the denominator part, we'll be focusing on the other fixed point. Okay, and the steps is the same. So we are going to find the difference between the two x coordinates, which is k minus 2, and the difference of the y coordinates, which is p minus 1. And then we square them, add them up together, and square root to find the distance. So here the distance would be the same as the first fixed point, so here will be 1 as well. Okay, so this is how we use the formula. So once we have done this, the rest of the steps would be simplifying only. Okay, so now to remove the square rule, what we can do is to square both sides. Alright, so with the square here, it applies to both square roots, so both square roots will cancel off with the square here, and here it's 1 divided by 1 in the square, so it's also 1. Alright, so what I'm going to do on the left side is I'm going to expand it out, okay, and the result will be something like this, and right side is just 1. Okay, so what I'm going to do is to move the denominator to the right side, and then I'm going to move all of these values to the left, okay, to simplify even further. So for the k square and the p square here, all will be cancelled off, and all of these values will be moved to the left side, and minus it together to get this result. Okay, so now it says express k in terms of p, so k on the left, everything to the right. And here, if you see the values here, we can actually simplify it. Okay, so both sides we are going to divide it by 4. So this would be the result. But just to let you all know, the answer given in the answer sheet and mine is a bit different, but I think theirs is wrong. Okay, reason is because if I want to express k in terms of p, I'm going to move negative 3k to the other side. So here will be 3k, and this p will be going to the right side. So here is negative p, negative 3. And then if I move this 3 to the other side, it will become k equals to negative p, negative 3 over 3. Which I'm not sure where is the negative here. Okay, because here there should be a negative. Alright, and once we get this one, we should factorize the negative out. So here will be p plus 3 over 3, which is same as my answer. So this should be the correct answer. Alright, and with that, we have completed the discussion of this paper. So if you have any questions regarding this paper, feel free to put your questions in the comment section below. And I know now you all are having your SPM right now, so I wish you all the very best on your upcoming papers. Alright, so thank you so much for watching, take care, and I'll see you all in the next video. Bye bye!